All right, hey guys. So this is a supplementary video, and I'm making this because I'm seeing a need amongst the students that I work with simplifying square roots, right? And when we're working with the quadratic formula, you're going to often get things that are not perfect square roots, right? So for example, and what I'm talking about here, and this will make perfect sense to you in a second, is let's say I have, the square root of 25, right? And most of us are pretty good on that, and usually with the quadratic formula, there's always that plus and minus thing, right? And so it's plus and minus 5, right? And we're like, oh, this is easy, right? Square root of 64 is, plus and minus 8 and all of that. So this isn't what I'm talking about, because all you have to do to get good at those, honestly, is just make a chart for yourself and just go 1 squared, 2 squared, 3 squared, make that equal to 1 times 1 equals 1, 2 times 2 equals 2, or 4, 2, right? Mr. Simons, wake up. 3 times 3 equals 9, and you can go down the list, right, and make that, right? And it would be helpful. I'd recommend that to everybody. But that's not what I'm talking about. What I'm talking about is, what do we do when we get something that isn't one of these square numbers? That's what a square number is. 4 is an example of a square number, right? It's a square number. So I want to know, what do I do when I get something that's like the square root of 8, right? What do I do? How do I leave it? What's the idea? And so there is a clear cut path of what you want to be able to do, and a couple different strategies you can go about using it. And I want to try to start going over some of this stuff with you guys. All right. And so why don't we start with the square root of 8? Okay. So I'm going to kind of move this off to the side here, and we're going to go square root of 8. All right. So the thing we have to recognize is that there's a bunch of square root properties, right? But square roots, kind of dealing with them is sort of like dealing with it's a lot like dealing with regular numbers, right? And I know that if I have something that's 8, right? I know that I can make that by multiplying 2 numbers to get 8, or even 3 or 4 or whatever, right? And with 8, it's just 2, right? And so the 2 ways I can get 8 is I can get 1 times 8 is 8, right? And the other factor pair for 8 would be 2 and 4, right? So those are those 2 factor pairs that I can use to get 8. Okay, and so what we are looking for when we're trying to simplify a square root is we're trying to find something where one of the factor pairs, right, one of the parts, right, one of the factor pairs has a number that is square. So we want a number that is one of these square numbers about what we're talking about, right? So we want something that's, and if I list my square numbers, right, I think got 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, and I'll stop there because I don't think we're going to do anything much higher that's going to require us to need any of that, right? Those are my square numbers, right? Those are my square numbers. So ask yourself, is there a pair of factors that make 8 where one of the numbers, right, is a square number? Well, yeah, 4 and 2, right? And so I can write this using the square root property like this: square root of 4 times the square root of 2. Okay, because you can just combine radicals when it's the same roots. When we're doing square roots, which is the second root, right? You can just break it apart like that. Okay, and now the great thing about that is I can actually simplify this, right? The square root of 4 is 2, and then it becomes 2 times the square root of 2. Okay, so it's all a matter of just kind of busting it up, and you do that until you can't go anymore, right? And that's the whole idea of working with factor pairs and how we want that to look. All right, so let's do some more. All right, so let's say I have the square root of 10. Okay, and you're like, oh great, I'm going to find a square number that works into that. Well, the square numbers that are less than 10 are 1, 4, and 9. And to the best of my knowledge, And when we talk about 1 isn't really very useful, right? So never think of like 1 and 10 as like a viable pair of factors for simplifying these things, because it's not really going to help you. So 1 and 10 is kind of off the table. So the only other factor pairs I can think of are 2 and 5. The problem is neither one of these is a square number. So square root of 10 is actually in simplest form, right? So this one you would just kind of leave how it is, right? So you'd go, all right, good, that's good. Let's do another one. Square root of 12, all right? We're gonna do some of the higher numbers in another video. So square root of 12, right? Think of all your different factors of 12. So you've got 1 and 12. We discussed that. Those are kind of dumb. 2 and 6, neither one of those is a square number. And then 3 and 4. And look at that, 4. 4 is a square number. So I can write this as square root of 4 times the square root of 3. Square root of 4 simplifies, right, to give me 2, right? And then you have 2 times the square root of 3. And that is the simplified form of square root of 12. They're the same, right? But we want to be able to simplify these things because sometimes that gives us the option, especially with quadratics, to make things clean up a little better. Okay? So let's try another one. So I'm going to give you this one right here. So I want you to try to see if you can find a pair of factors where one of 20 that multiply to give you 20, where one of them is a square number. All right, so pause the video and try to figure this out, and then come back. All right, so hopefully you tried this. All right, so we've got 1 and 20. That's, that's not going to work, right? And we've got 2 and 10. Neither one of them is a square number, right? And then the only other one I know about is 4 and 5. And look at that, we got 4, right? 4 is a square number. So let's write this as the square root of 4 times the square root of 5. So this is going to be 2 times the square root of 5. And what you'll find as you start doing more and more of these guys and getting more comfortable with them is that usually if you're looking for, I'm always looking for, can I pull 4 out of this? Can I pull 9 out of this, right? Out of your number, right? Out of that main number, so that I can get a 2 or a 3 when I square root it. Right? Those are the ones that appear the most often, that are going to actually give you, like, something where it's going to be helpful. Okay? So let's do just a couple more. All right? So let's do the square root of 21. All right? So the square root of 21 is, I can rewrite this as 3 and 7, right? Well, that doesn't really do anything, right? Or I could write it as 1 and 21, and that doesn't really do anything either. So when you have the square root of 21, this is in simplest form, right? Simplest form, right? So some of these, even though they're big numbers, you can't do a lot with them, and it's kind of frustrating. You look at it and you're like, what the heck? 30 is like that, right? You can't pull anything out of 30. That makes sense. Okay, so let's look at 28. All right, 28. I'm going to do 2 more. All right, so 28, we're going to do, let's think about what our factors are. So we got 1 and 28. That's not going to help, right? We've got 2 and 14. Well, 14 is not a square number. 2 isn't either. But 4 does go evenly into 28. And then we can pull 4 out, right? So we got the square root of 4 times the square root of 7, which gives us 2 times the square root of 7. And, all right, so our last example is the square root of 27, right? So factor pairs, right? Obviously, I can't pull 2 or 4 out of that because it's an odd number, right? So 27, let's see, you could do 1 and 27, or the only other factor pair I know is 3 and 9. And 9 is a square number. We like 9, right? So if I pull out, rewrite this as square root of 9 times the square root of 3, then this becomes 3 times the square root of 3. Because you take the square root of the one that you can actually square root, right? And when I'm being goofy, I'll say square rootable, right? And then you multiply it times that, and you're in good shape. Okay, so 3 times the square root of 3 is what you have there. And so this is kind of a not necessarily quick, but a bit of a tutorial on how do we deal with simplifying square root expressions that aren't perfect square numbers. All right, and so there'll be one more video where we're going to do some larger number examples. All right, and so we'll see you there.